Not only our digestions, during the emotions also you will cry, right? Whereas in the chemical change, remember, entirely new different product will be obtained. In our daily life also, so many chemical reactions will be taking place in our body. How to balance that equation also, just now we have learned. Hello my dear students, welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last session, we were dealing with the matter. And also, we have understood that it is very important to study about the matter, right? So, under that, we have understood that the matter can be broadly classified into two types. Which are those? One is a physical classification and second one is based upon the chemical classification, right? Under the physical classification, we have seen that the matter can be exist in three different states. Whereas in the chemical composition, based upon this, the matter can be broadly classified into two types. Which are those? A pure substances and a mixture. And also we have understood that a pure substances is again classified into two types, the elements and the compound. Again, in the mixtures, it is two types, that is homogeneous mixtures and a heterogeneous mixture. Now, we'll move towards the next topic. Again, in our last session, remember, you also learned about the structure of atom. Under that, we have studied that what is an atom, how to represent the atom structure, how to represent the number of shells, and what will be the valency, what is the atomic number, what is the mass number, and how do we calculate this valency also, we have discussed. Today, let us move to the next topic, that is about the chemical reactions. Okay? Before going to understand what is a chemical reaction, I will give you two examples for you. Okay? Imagine you have a two piece of paper. Okay? In one hand, what you are going to do, you are just crushing the paper. On another hand, you are going to burn the paper with the help of matchstick. After observing these two changes, what you can say? Can you name the example for this? Changes which is taking place in both the example. The first example can be named as a physical change. Because if you take a piece of paper and if you crush, only the physical state of a substance is altered, right? Hence, it is the example for the physical change. Okay? Or else, if you take the paper and if you tear the paper also, it is the example for the physical change. Coming into the chemical change. If you take the paper and if you burn with the matchstick, we know that the paper will burn and produces the ash. That shows that it is the example for the chemical change. When did we say that it is a physical change and a chemical change? Only when a new product, if it is formed, then we named as a chemical change. When only the physical state of a substance, if it is changed, then we say it is a physical change. So there is a lot of differences between the physical change and also in the chemical change. Remember, in the physical change, only the physical state of the substance is altered. Okay? It may be color, it may be shape, whatever it may be. Whereas in the chemical change, remember, entirely new different product will be obtained. Right? That is why it is named as chemical change. Hope you all understood with the physical change as well as with the chemical change. Now let us understand what is a chemical reaction. When it happens. Okay? When I say it is a chemical change, okay, the reactant must be converted into product. Okay? The reactant will undergo the transformation and forms a product either by bond breaking and also by bond making. So either by bond breaking or either by bond making, it will form a product. Such kind of reactions are known as a chemical reactions. When the reactant, if it is formed into a product, then you say it is a chemical reaction. Remember, during the chemical reaction, always the reactant will be converted into product. The reactants will be converted into product. The best example I can give you is, here I have taken an example of the hydrogen and the oxygen. Okay, the hydrogen and oxygen elements, they are the example for the reactant. They are combined together and forms a new product, and that is a water. This is the example for the chemical change. Because entirely new different product will be obtained because of the chemical reaction. That is why it is named as a chemical change. Okay. So chemical reactions are nothing but the reactions where the reactant will be formed into product, either by bond making, either by bond breaking. So such types of reactions are known as chemical reaction. Remember, the chemical reaction always it undergo chemical changes. So this is a small introduction to the chemical reaction. Hope you all understood. Now let's see which are all the chemical reactions which also taking place in our daily life. We all know that in our surrounding, so many different kinds of the reactions will be taking place for every 5 minutes. For every minute, we can say that the number of reactions will be taking place in our surrounding. Here, I have listed out the few examples for the chemical reactions which is taking place in our daily life. The best example is combustion. Have you all seen the combustion? Combustion, it is nothing but a burning of coal or burning of hydrocarbon or burning of wood in presence of oxygen. What happened? If you burn the wood in presence of air, it will convert it into coal, right? By producing the carbon dioxide and also by producing the ashes. Where what happened? The wood is converted into ashes or a coal. A completely new product will be obtained. Hence, it is named as a chemical reactions. Okay. Another example I can give you is rust. We all familiar with the rusting, right? When you keep on exposing the iron nail in presence of the air, what will happen? The iron reacts with the oxygen which is present in the air and forms the rust. Rust is a kind of layer which is deposited over the iron nail. It is an example for the chemical change, or we can say it is an example for the chemical reactions, because the iron nail get the depositions of the rust. Right. So, entirely a new product which is obtained because of the changes. That is why it is classified under the chemical reactions. And another example is digestion. So, we all know that we used to take the solid food. Once we take the solid food, where it will goes? It will directly goes to the food pipe. Then it will enters to the stomach. In the stomach, we all know that the hydrochloric acid will be produced. Hydrochloric acid will be produced. What happened? So, you are taking the complex food, right? Complex food. The HCl gas will be produced in the stomach. It will convert the complex food into a simple food. This is how in our daily life also so many chemical reactions will be taking place in our body. The best example is a digestion only. If you take any food, it will go to the stomach. In the stomach, it will combine with the hydrochloric acid which is produced in the inner layers of the stomach, and it will form a new product. Or we can say that the complex food will be converted into simple food for the further ease of digestion. And other example I can give you is photosynthesis. So we all know that green plant easily it will prepare the food, Do you know why it easily prepares the food? Because of the carbon dioxide which is present in our surrounding, right? The carbon dioxide which is present in our surrounding will be absorbed by the green plant, and also it gets the water from the root, and in presence of sunlight, it produces a food, or it will prepare the food. That is in a C6H12O6. C6H12O6, that is nothing but a food. That is also known as starch. Okay. This is how even in a green plant, during the preparations of the food, the chemical reactions will be taking place. In our body also, so many chemical reactions will be taking place. If I am standing this, a kind of chemical reactions will be taking place in my body just to stand in front of you and I am explaining to you, right? My mind is working and so many organs are working here so that I am easily explaining to you. Not only our digestions, during the emotions also you will cry, right? So during the emotions what will happen? So many hormones will be produced in our body. That is an example for the chemical change. So you can list out so many examples for the chemical changes which is taking place in our surrounding and also in our body. Another example rather than this is in your kitchen. We all know that we used to cook the food with the help of rice and also with the help of vegetables, right? So during the cooking also, whatever the materials you used for cooking, it will be get converted into form a new product. Hence, it is an example for the chemical changes. While during the preparations of the roti also, what you will prepare? While doing the preparations of the roti, first you will prepare the dough, right? After that, by using the dough, you will get the roti. This is how the chemical reactions, it become a part and parcel of our life. And you can list out the plenty of examples for the chemical reactions and the chemical changes which is taking place in our surrounding. Now, let us understand writing a chemical equation. After knowing a few things about the chemical reaction, we must know that how to write the chemical reactions also, or the chemical equations. So what is this chemical equations first? Do you know what is chemical equations? Chemical equations are nothing but a symbolic representations of the reactant and the product in terms of symbols or by using the formula. That is said to be chemical equations. What is chemical equation? It is a symbolic representations of the reactant and the product either by using the symbol, either by using the formula. That is known to be as a chemical equation. Here I have used the hydrogen as H, right? And oxygen as O. We are using the symbols for the elements just to represent the reactant. Same as that in a product, to represent the product also, we are using the symbols of that particular element. Then we say it is a chemical equations. Okay? Remember, while writing this chemical equation, you have to write this reactant on the right hand side and the product on the left hand side. And if the two or more reactants are involved during the reaction, you have to show the plus. Okay, in between two reactants, you have to show the plus charge, and if it is forming a product, you have to show the arrow mark. That is very necessary. Okay, you have to show the arrow mark for indicating the formations of the product. So what you have understood here? While writing the chemical equation, we must know that we have to write this reactions by representing the reactant and the product in terms of symbol or by using formula. Okay. While writing this chemical reaction, know that the reactant should be present on the right hand side, whereas the product should be present on the left hand side. If two or more reactants are involved during the reaction, you have to show a plus charge in between the reactants. If it is forming a product, okay, you have to show the arrow marks for the formations of the product. After this, if you know how to name this reactant and the product, so it is better to write the reactant name and the product name. And it is very simple to write the reactions in terms of chemical equations. The best example I have listed out here, that is hydrogen. It is an element, okay, combines with the oxygen forming water molecule. Okay, and if you know that the reactants are present in a which physical state, you can mention. Here I have used the word G. So that represents that the hydrogen which is present in the gaseous state. Okay, whereas the oxygen also which is present in the gaseous state. But these two gaseous state of hydrogen and oxygen, once it combines, it forms a liquid water. It forms what? Liquid water. If you take the other example is zinc, that is Zn. Remember, the first letter should be capital letter and next letter should be small letter. Okay. So, zinc which is present in a solid state, which is combined with a chlorine, which is a gas. So, it forms a zinc chloride, which forms what? Zinc chloride, which is in a solid state. If you don't know the physical state of the reactant and the product, don't worry. If you know only, then you write. Okay. Next is hydrochloric acid. So, that is present in a aqueous state. Aqueous state means to the solid state of a substances, if you add the water, it will be forms a aqueous state. So, aqueous state means a solid substances which contains a water. Hence, it is said to be aqueous state. So, here hydrochloric acid combines with sodium hydroxide, forms a sodium chloride, that is also aqueous state, along with the release of water molecule, that is a liquid state. This is how we are going to write the chemical reactions by using a chemical equation. Remember, chemical equation, it is very simple. We are symbolically, or we can say that we are representing the chemical reaction by using the symbols, okay, or by using the formula. Especially to show the reactants and the product, we using the symbols and the formula just to represent the chemical reaction. Then it is said to be chemical equations. Okay, and in the chemistry, it is very important to know that writing a chemical equations, and it is very simple also once you learn. Next is balancing of chemical equation. Ma'am, already we come to know that what is a chemical equation. Why we necessary to do the balancing of chemical equation? Balancing means here we have to balance the reactant with the product. We all learned that according to the law of conservation of mass, we have learned in the 9th standard, that is the number of atom which is present on the reactant side should be equal to the number of atom which is present on the product side, right? So, the number of atom which is present in the reactant side should be equal to the number of atom which is present in the product side. Then we say it is a balanced chemical equation. When we say it is a balanced chemical equation, when you take any chemical equation, the number of atoms on the reactant side must be equal to the number of atoms on the product side. Then only we can say it is a balanced chemical equation. How to do this, ma'am? Here I have taken the example of a nitrogen which is combining with the hydrogen and forming a product, that is NH2. Okay. Here we have to count the number of atoms on the reactant side and we have to count the number of atoms on the product side. That is the first step. Okay. How to count? So here N2 means 2 hydrogen, right? 2 nitrogen. Okay. H2 means 2 hydrogen. So on the reactant side only 2 nitrogen and 2 hydrogens are present. Coming into the product side, you can see that only 1 nitrogen is present and 2 hydrogen will be present. Sorry, just 2 hydrogen. Okay, yeah, 2 hydrogens will be present. Now we have to balance this equation by making the number of atoms on the reactant side should be equal to the number of atoms on the product side. How to make this? Just look at this slide, you can understand. Here we have 2 nitrogen, but there we have only 1 nitrogen. So I'll write 2 here. It is NH3. So it become NH3 only, that is 3 hydrogen. Okay, that is forming ammonia. Okay. So now we have balanced the nitrogen, right? So here we have a 2 nitrogen atom, but in the product side we have only 1 nitrogen atom. That is why I have written the number 2 in front of the nitrogen. So it becomes 2 nitrogen. So remember this 2 which is belonging to the nitrogen as well as for the hydrogen. What happens? So 2 nitrogen and 2 into 3 hydrogen. What happens? 2 into 3 hydrogen. 2 3s are 6. It becomes H6, right? It becomes H6. But now we know that on the reactant side we have only 2 hydrogen. To make it as 6 hydrogen, I'll write 3 here. Now if you multiply 3 hydrogen into 2 hydrogen, 3 2s are 6. That is H6 only, right? So if I write 3 in front of the hydrogen, so it becomes a 6 hydrogen atom. So now nitrogen is balanced. We have written 2 in front of nitrogen. So 2 nitrogen. So nitrogen atom is balanced. Coming into hydrogen. Already the 6 hydrogen is there, but here 2 hydrogen is there. To balance this, I have written a numerical called as 3 in front of hydrogen. So it forms a 6 hydrogen. This is how each number of atoms on the reactant side should be made equal to the number of atoms on the product side. When you balance this equation, when you balance the number of atoms on the reactant side and the product side, then only we can say it is a balanced chemical equation. Okay. We'll take the other example. Can anyone try for this? Here we have 2 iron atom, that is 2, and 3 oxygen atom and 1 carbon atom, right? So we have 2 iron atom and 3 oxygen atom and only 1 carbon atom on the reactant side. Then coming into the product side, you can see that only 1 iron atom is there and 2 oxygen atom is there. Then only 1 carbon atom is there. So only 1 carbon but 2 oxygen atom will be there. How to balance this? First I'll go for the iron. Since there are 2 iron atom is there, I'll write 2 in front of iron so that it becomes 2 iron atom now. So 2 iron atom is balanced. Okay. Coming into the oxygen. How many oxygen atom is there? Here 3 but here 2. How to make it same equivalence? So I'll write 3 here. Okay. If I write 3, what happened? 3 into 2, 6. 3 into 2, 6. Suppose if I write 2 here, again also this 2 will be belonging to the iron and 2 is also belonging to the oxygen. Right? So 2 into 3 oxygen is again 6 oxygen. Here 3 into 2 oxygen means 6 oxygen. But remember, when you write 2 in front of this entire reactant, the 2 which is belonging to the iron, we already balanced the iron atom. But now if you count 2 into 2, it becomes 4. Here we have written only 2. So you can change once again. So it becomes 4. So while writing, you have to see each atom whether if it is balanced or not. So while writing this balancing of equation, write the reaction in the pen. While balancing, use the pencil. After once you balanced, you can use the pen. This is how we need to step up to learn for the balancing of equation. Already I have written for the iron, but when you add 2 to balance the oxygen, it becomes 4 iron atom. That is why I am writing 4. So 2 into 2 iron atom, it becomes 4 iron atom, and here 4 iron atom. And 2 into 3 oxygen atom, here 2 into 3, 6 oxygen atom. But remaining, there is only 1 carbon atom is there, but in this side we have written 3 for balancing the oxygen. To balance that oxygen we have written 3, but it is also belonging to the carbon, right? It also belonging to the carbon. So we have to write 3 here. So 3, 3. So 3 carbon, 6 oxygen, 6 oxygen, 4 iron, 4 iron. So it is very simple. You can play with this balancing of equation by taking a number of examples. And it's very simple to make it the equivalence between the number of atoms on the reactant side to the number of product of the number of atoms on the product side. We'll come into the third example. Here I have taken the Al, that is aluminium. So there is only 1 aluminium will be there, and here you can see that in the product side 2 aluminium atoms are there. But here if you count the hydrogen, 3 into 2, there are 6 hydrogen atom will be there. But we know that this 3 which is belonging to the hydrogen as well as for the sulfate. That is right. So 3SO4 means a 3SO4 thrice. Yeah, 3SO4. So now if you balanced, here also the 3SO4 will be there. Okay. But here only the 2 hydrogen atom will be there. Now we have to balance a number of atoms on the reactant side to the number of atoms on the product side. Here since we have only 1 aluminium, but we have a 2 aluminium here. So for that I'll write 2 in front of the aluminium, so that aluminium is balanced. So 2 aluminium, 2 aluminium. Next, coming into the hydrogen. How many hydrogen atom is there? So 3 into 2, 6. But how many atom is there on the product side? Only 2. So that I can write 3 here. So that 3 into hydrogen atom is 3 into 2 hydrogen atom is, it becomes 6 hydrogen atom. Okay. So it becomes 6 hydrogen atom, and here 6 hydrogen atom will be there. Again, so if you see this sulfate, SO4, 3 sulfate will be there and 3 sulfate will be there, SO4 thrice. So this is how we can easily play with the naming of the each and every equation. You can play like with the balancing of the equation, and it is very simple. I hope you all understood how to balance the chemical equation. Remember, while balancing, number of atoms on the right hand side should be equal to the number of atoms on the left hand side. Okay. Now we'll move on to the types of chemical reactions. When I started saying the chemical reaction, we have understood that all the chemical reaction which undergo chemical changes, and while writing this chemical reaction, we must aware of that chemical equations also. Chemical equation means symbolic representations of the reactant and the product by using the symbol. And also once you write the reaction or the chemical equation, we must know that we have to balance the equation. Right? How to balance that equation also just now we have learned. Now we are going to understand the types of reaction. Once you go through all those things, we can easily go for the types of reaction. In this, I have listed the 5 different types of the reaction. I hope you studied in a 10th standard, right? So let's study this. First one, combinations or the synthesis reactions. In a combination reaction, remember, always 2 or more different reactant, they combine together and forms a single product. Here you can see that, imagine A and B are the 2 different reactant, they combine together forming a single product, that is AB. The best example I can give you is magnesium combined with the oxygen forming magnesium oxide. Here, the two different reactant, they are combining together and forming a single product. Two different reactant, they combine it together and forming a single product. That is said to be combination reaction. Coming into the second one, that is decomposition reaction. Decomposition reaction means a single reactant will be undergo decomposition and forms a two or more elements. Two or more elements, if it is formed, then it is said to be a decomposition reactions. Okay, the best example is a water. Okay, during the electrolysis, this hydrogen, that is a reactant, undergo decomposition and forming hydrogen and oxygen. A single reactant which undergo decomposition and forming a two or more different elements, then we say it is a decomposition reaction. After writing this, we have to balance the equation. How many hydrogen is there? 2. But 2 oxygen is there. Here only 1 oxygen is there. So I'll write 2 here. If I write 2 to balance oxygen, again it will be also added to the hydrogen. So 2 hydrogen, 4 hydrogen and 2 oxygen, 2 oxygen. So this is how, after understanding the chemical reaction, we have to write the reactions in a chemical equation and we have to balance the equation. And third one is single replacement reaction. Remember, single replacement reaction can also known as single displacement reaction. What happens in this kind of reaction? Remember, a more reactive elements are always replaces with less reactive element and forming a product. A more reactive element always replaces the less reactive element and forming a product. Such kind of reactions are said to be a single replacement reaction. Okay. The best example I can give you is iron, okay, and also copper sulfate. We know that iron is more reactive than the copper, so that iron will be replaces with the copper and forming iron sulfate and copper as a less reactive. Such kind of reactions are known as a single replacement reaction. Only the replacement of the reactants will be taking place with the higher order to the lower order. Highly reactive elements will be just replaces with the lower reactive element and forming a product. Such kind of reactions are known as single replacement reaction. Just it is a replacement of the reaction. Coming into the double displacement reactions or double replacement reaction. It is also quite simple. Here, only the replacement of the ions will be taking place between the two reactant. If you take any two reactant, okay, only the replacement of the ions will be taking place and forming a product. Such kind of reactions are said to be double replacement reactions or double displacement reaction. Example is, if you take the example of barium chloride, okay, BaCl2, which is going to react with the sodium chloride, Na2SO4, sodium sulfate, forming. Here, I have said that only the replacement of the ion which is taking place. What happened? The sodium react with the chloride and the sulfate react with the barium and forming sodium chloride, 2 sodium chloride because it is Na2 plus sulfate reacting with the barium forming barium sulfate, This is how only the replacement of the ion which is taking place between the reactant and forming a product, such type of reactions are known as a double replacement reaction. The last one is a combustion reaction. The combustion means we all know that the carbon combines with the oxygen forming a carbon dioxide. It is an example for the combustion. Or if you take any hydrocarbons, okay, it may be a wood or it may be coal, okay. If it is burned with the air which containing oxygen, forming a carbon dioxide and produces a huge amount of the heat. That is why when you burn the wood in presence of the air, it will combine with the oxygen and forms the carbon dioxide along with a huge amount of heat. Such kind of reactions are said to be combustion reaction. Okay, the best example I can give you is the carbon, that is the coal. If you burn the coal in presence of the oxygen, that is in the air, it forms a carbon dioxide along with the release of the heat. Along with the release of the heat, we can see the release of heat only in the combustion reaction. This is how a number of types of the reactions you can name. So the few basic types of reactions I have listed out. Don't forget this type of reaction. First one is a combination. Second one is a decomposition. Third one is a single replacement. Fourth one is a double replacement. And fifth one is a combustion reaction. Okay. Don't forget this type of reaction, and you know that what is a chemical reaction, and you know that how to balance the chemical equation, and you have learned with how to write the reactions in terms of equation. Okay, so in the next session we are going to deal with the next topic. Okay, that will be quite interesting, like as we have done today. Till that, think like a proton and stay positive. Okay, I like to say that a person who working like a person who works positively, he is always like a hydrogen bonds of motivator. Always I am repeating these sentences at the end of my session that makes you to work like a proton and stay positive. Thank you.